Okay, we'll continue our discussion on the single shaded pole induction motor. This is one of the special motor. That means I'm not using the concept of like what we discussed in the previous case, split phase concept. Here this comes under the category of special motors. Okay, so each motor is operated with separate special concepts, special principle, separate principle. You know, not the same as the previous. That's why these motors like AC series motor, universal motor, hysteresis motor, stepper motor, all this comes under the category of special motors. That means each motor has works on the principle of separate new concept. Okay, so let's try to discuss the shaded pole induction motor. What is this shaded pole induction motor? So I'll try to just show you this. Okay, the diagram physical construction here. I'm considering this is a four pole induction motor, 4-pole shaded pole induction motor. Okay, again it's a single phase induction motor, but it's not the split phase concept. It is comes under the concept shaded. So now what it will do here? Now here if this is a pole, which pole? If this is a rotor stator pole here, okay, this stator pole, what I will try to do here, you can see the diagram here. Okay, why it is not straight, why it is in semicircular, you already know this. It is semicircular to provide uniform flux distribution, uniform flux distribution between the uniform flux distribution, so that the EMF waveform should be sinusoidal. Okay, as it is in semicircular here, I'm not considering here. I'm slightly cutting the some portion of this pole here. I'm slightly cutting this some portion. Okay, so that what happens here, it is divided into two halves here. Okay, it's again justifying the same formula here, phi 1 phi 2 sin alpha with single phase. This which supply I'm giving here, single phase supply. With single phase supply I'm only getting this phi m. What is the nature of this phi m here? It's just alternating. Is it rotating? No, it's not rotating. For that I need to find out some other flux. That is phi 1 phi 2 sin alpha. Okay, so that means phi 1 phi 2 sin alpha. So what I will do here, I will try to make a small cut so that this will be divided into two parts. One is with 2/3 portion, other one with 1/3 portion. One is with 2/3 portion, other one is 1/3 portion. Okay, 2/3, other one is 1/3. Now what I will try to do here, okay, I will try to add one copper band. I will try to add one copper band here. Okay, copper band to this. I'll try to wear. That is, I will try to insert some band, copper wire around it to the small portion, 1/3 portion. So that is, it's a conductor. It's a wire. Okay. Now why I'm all doing this? Let me try to just tell you here. So I'm inserting this copper band around the small portion. Now here you already know this. Whenever a current carrying conductor is placed under the magnetic field, a torque is generated, and the second thing is when a conductor is placed, when a rotating conductor is placed under the magnetic field, then a EMF is generated here. So let's try to use this Faraday's law concept. Now this supply is given here, and due to this supply here, the flux is generated. Due to this supply, the flux is generated. As flux is generated here, this flux tries to cut this conductor. Okay, tries to cut or link. Cut is nothing but generators. Linking is nothing but transformers. I guess I don't want to get into the basics of the term here. So we can able to generate EMF in two ways: dynamically induced EMF as well as statically induced EMF. Dynamically induced EMF is nothing but if there is any rotating part, that concept is called as dynamically induced EMF. If there is no rotating part, like transformer, still if I give AC supply, we can able to generate the EMF even then also. That type of EMF is nothing but statically induced EMF. Okay, that type of EMF is nothing but statically induced EMF here. Here, what I will try to do here, I will try to, okay, once the winding is once the part is, okay, it is generated here, this rotating flux will try to link with this copper band. So this copper band, what it will try to here, it will try to generate some currents. We will say that some circulating currents or currents within the site. It's a closed path. So whenever the rotating part is in stationary, the conductor which is linking with the flux, which flux? Main flux. Conductor which is linking with the main flux. The nature of flux, what is the nature of flux here? It is alternating nature. Is it varying with respect to time or not? So flux is varying with respect to time. and conductor is there. So is there any relative motion or not? Relative motion is generated there. So that what happens here? A current is generated. A current is generated where? In the shaded pole. Whenever current is there, we have a relation. What is the relation here? Whenever current is there, always I is proportional to phi. Whenever current is there, flux generates. Yes or no? By default, both are interrelated and interdependent. Whenever current generates, flux generates. Whenever flux is there, by default, that means current is there around it. Okay? Flux is there around it. That means as current is generated here, even the flux is also generated. That is this shaded coil. I am calling this portion as shaded coil. In the shaded coil, current is generated because of the statically induced EMF concept. As current is generated, flux is also generated. Now, how many fluxes are there here? There are two fluxes are there. One is phi s, other one is phi m. Ultimately, what I need to do here, I need to bring the starting flux into the machine by some means. In the split phase, I am adding new winding, auxiliary winding. Here, what I am doing here, I am cutting this portion, some portion of the pole, and I am inserting the winding. That winding I am calling it as a shaded coil or shaded winding. Now here, wind is kept idle. Now, when the supply is given here, due to the time varying nature of flux, an EMF is generated here. This EMF is generated in the coil, and due to this EMF, voltage is generated, current is generated, and flux is also generated. This new flux I am calling it as starting flux. Now, how many fluxes are there in the machine? Two fluxes. One is main flux, other one is shaded coil flux. We'll try to specify particularly. We'll call it as shaded coil flux is there. So two fluxes are there. When two fluxes are there, what is the formula here? Torque is proportional to phi 1, phi 2, sin alpha. This phi 1 is main field flux and the phi 2 is nothing but shaded coil flux. So that is it developing a phase shift between the two fluxes or not? When two fluxes are there, definitely the phase shift is generated. Then can I able to conclude that torque can be generated or not? Unlike if I only have single phase supply, can I able to generate the torque? We cannot generate the torque. We already justified the same by using the double field revolving theory. Now, wantedly, I am incorporating this. Okay, I am splitting this, cutting some portion, and placing the winding in the cutout section. So that what I am saying, EMF is generated in the coil and current is generated and flux is generated. So that I am introducing new flux. So now two fluxes are there. Same redraw the phase diagram, whatever you drawn. Okay, now just now we have drawn. This is IS, IM, and this is IS. The resultant is IT. Okay, now. So in this manner, we can able to generate the torque. We can able to generate the torque here. So this is how the shaded pole works here. So we need to be little bit elaborative. Okay, as you can expect this for 10 marks here. So there we will try to see three cases here. Okay, so I hope now you understood how in shaded pole induction motor how the rotor rotates. Ultimately, we need to see that how the rotor rotates. That's what we see that. So by introducing the one extra additional flux, we can able to see that the rotor can be rotated. Okay. Now, I hope everyone knows Lenz's law. What is Lenz's law? Simple definition. It opposes the cause produced by it. Lenz's law, it states that it opposes the cause produced by it. You know, it states that it opposes the cause produced by it. It opposes the cause produced by it. If someone is trying to help you, okay, once you are out of danger, again you are throwing him again into the same place. Okay, it's like doka. You know, it's okay. Okay, I hope it's like Bahubali Katappa. Okay. Okay. So Lenz's law also does the same. Okay. So it's generated because of the some cause. Again, it is opposing the cause here. It is opposing the cause. So why I am using this Lenz's law here? That means I'll try to show three diagrams. Which is important here. Now here, let's assume that there are three cases here. What is the nature of the alternating current here? You can see that the current is this is the shape of the current. Yes or no? I will try to consider here. The first portion is I am considering up to this extent here. What does it mean here? The current or voltage. All waveforms are in sinusoidal manner or not? The current or voltage, it is increasing. When current is increasing, how the shaded coil will act, how it will respond. When the second case is when current is at the maximum case. or at the constant. Okay, na? How the shaded coil will respond. Third case is when the current is decreasing. Okay, na? How the shaded coil will respond. When the current is decreasing, how the shaded coil will respond. We'll try to just see this simple with the Lenz's law concept here. Okay, so what it will try to do here. So we discussed three cases here. So one is when current is increasing here. What is the relation between current and flux? Directly proportional. When current is increasing, indirectly flux is also increasing here. When current is maximum, that is maximum value. When third case is when the current is decreasing here. In sinusoidal, all the three cases will happen here. Now here, when current is increasing here, how the shaded coil will respond? Okay. Now here, what is the main cause for the flux generation in the shaded coil? My question is, what is the main cause for the flux generation in the shaded coil? So let me try to write here. So that means, in order to generate the flux, first supply. Let me try to write on the steps here. First, supply voltage is given. When supply voltage is given, then current is supply current is generated here. Because of this, rotating flux is generated here. Main flux. This main flux will try to link with this shaded coil. And what happens here? Some voltage is generated in the shaded coil. Voltage in the shaded coil. This voltage in the shaded coil will also generate some current in the shaded coil. And ultimately, what happens here? Flux is generated in the shaded coil. This is the lengthy process. Supply voltage, total current, main flux, and because of the Faraday's law, EMF concept, voltage is generated in the shaded coil, flux is generated, current in the generated coil, and flux is generated in the shaded coil. Now, if I want to just shorten the things here, can I call this flux generated in the shaded coil as effect? Flux generated in the shaded coil is effect or not? Then what would be the cause here? Can I consider this as a cause? Main field flux is a cause or not? So I will consider this as an effect and this one as a cause here. Okay. So what the Lenz's law will do here? It opposes the cause produced by it. So this effect is generated because of the cause, main field flux. Now whatever the main flux, now it is there here. It is trying to oppose the cause. The effect is whatever the shaded coil flux is there. It is now trying to oppose the main field flux cause. That is, now what is happening into the main field flux here? The main field flux is about to increase. As you can see that in a sinusoidal waveform, as you can see that sinusoidal waveform, when it is increasing, the flux, when current increases, flux is also increasing here. So that as main field flux is about to increase in not, what is this shaded coil flux should do here? It should do opposite. Why it should do opposite? Just to satisfy which concept? Lenz's law. Why it should do? Because it's cause and effect here. The effect should always oppose the cause here. So that means that's why, okay, it is generating less flux in this portion. You can see yes, only single one or two lines. Why you can see only single one or two lines? Because it's generating less flux in the shaded coil. Why it is generating? Being an electrical engineer, you should be able to tell or justify that in the answer that why it is generating less flux in the shaded coil, because the main field flux is increasing. As main field flux is increasing, as per the Lenz's law concept, it is opposing here. The nature of the shaded coil flux should be opposed to the main field flux. That's why it is reducing. Now the main field flux is reached to the maximum value. In the sinusoidal case, the main field flux reached to the maximum value. Now when the maximum value that is constant, okay, when it is constant, is there any change here? When it is constant, even the shaded coil flux is also remains same. When it is increasing, shaded coil flux decreases. When main field flux decreases, shaded coil flux increases. When it is remains same, it will also remain same. Third case, we see that what does it in case here? It is decreasing. Main field flux is decreasing. You can see only one line. Now what this shaded coil flux should think that the main field flux is decreasing. Now it should do opposite to this main field flux. Now what it will do here? It will generate more amount of flux. That's why you can see the group of lines here and there here. We cannot able to generate the same in the PPT. It will be slightly difficult here. So that's why this is more amount of flux is concentrated in the shaded coil portion. Okay. So what I can conclude that magnetic axis. What do you mean by magnetic axis? The center of the magnetic flux, okay now, where the more the magnetic flux is concentrated, okay now? So you can see that the magnetic axis in the first case is located in the unshaded portion. I will divide the two portions as one is shaded portion and one is unshaded portion. Can I call this as unshaded? Yes or no? Can I call this as the unshaded portion or not? So this magnetic flux, okay, this axis, magnetic axis is located in which area? It's starting in unshaded portion. Why? Because more amount of flux is there at the unshaded portion. So that, okay, maximum magnetic axis will be also located in the unshaded portion only. Okay or not? Okay. So in the bus, let's assume that the bus's seat capacity is 50. So all the most of the passengers are sitting in the front only. Then the way in which tires the burden will be there? On front tires or back tires? Front tires. Okay. If it is majority of the passengers are sitting on the back side, then the burden will be on which tires? Back side. If all the passengers are equally distributed, then the burden will be on both front and back side. Similarly, I am also saying the same here. If the maximum, wherever the maximum amount of flux is there, their magnetic axis will be generated, located, confirmed. Here, as more amount of flux is there in which portion? Unshaded portion. So magnetic axis will be there in the unshaded portion. Now, as all the fluxes are, the flux is constant here. Okay, so there is no both in the unshaded as well as shaded, the fluxes remain same. So the magnetic axis will be at the where? Center. Okay. Whereas in the last case here, as the main field flux is decreasing, what is happening here? The shaded flux increasing or not? So our more amount of flux is available at the shaded coil. So magnetic axis is available at which portion? Shaded coil portion. Maximum amount of flux is available at the shaded coil portion. Okay. So AC waveform is one is increasing, constant and decreasing. Can you just conclude the things here? When main field flux is increasing, when current is increasing, when main field flux is increasing, Lenz's law is doing opposite to the main field flux. Okay, sorry. Shaded coil flux is doing opposite to the opposite to the main field flux. By which concept? Lenz's law. When it is increasing, the flux is in the shaded coil is reduces. It is reduces, and magnetic axis is available only in the unshaded portion. When flux is constant, main field flux is constant, the magnetic axis is in the middle. When flux is decreasing, main field flux is decreasing, shaded coil flux is more. So magnetic axis is available at the shaded coil portion. You can see that one of the previous competitive exam bit here in Genco and Transco here. What is the nature of the magnetic axis in shaded pole coil? Is it shifting? The options are like this. It is shifting from shaded coil to unshaded portion, or an unshaded portion to shaded portion. Both, none of the above. What is the answer? Unshaded portion to the shaded. I hope now you are remembering the question. Okay. So the flux is, the main magnetic axis is shifting from the unshaded portion to the shaded portion. You should be able to justify by using this diagram. Okay. The expression is also given here. This is all the shaded coil here. So again, I am incorporating one new flux by using the shaded ring or shaded coil here by cutting this. And what are the advantages here? It is economical and reliable. Construction is simple and robust. It can work even in the difficult conditions here. And there is no centrifugal switch like in the split phase. In split phase, we will be having centrifugal switch. Even if there is a damage, there will be a problem. But here we don't have any split phase. No moving spots here. What are the disadvantages here? Power factor is very less. And starting torque is also less. And efficiency will also less. Okay. In special motors, we were more bothered about its purpose, not on the efficiency. Okay. Where we use these applications here? We use in hair dryers, toys, record players, small fans. Normally nowadays everyone is using the small fans, chargeable fans. Okay. Electric clocks. Okay. Applications are in coinciding here. Okay. All these things happen. These are the applications of shaded pole machines. I hope this concept is clear.